Fundamentally, teams are excited to build, workflows in Dagster, and they're tired of doing it on Airflow.
So stability was a very, very big pain point for us at Airflow. We've had numerous outages whereby Airflow just simply wouldn't run our jobs, would refuse to run our jobs, or sometimes the Kubernetes pod operators just fail to even start or just fail midway during the processes.
XComs, they are a sore subject. You can only pass in limited amount of data between tasks.
It wasn't a system that people loved going to and working with. There were a lot of shim scripts to push stuff onto the remote system. There was no CI/CD or testing.
To even do one iteration of our change, not even an end-to-end cycle time, just do one iteration of a change, it's 10 minutes.
The biggest pain point with Airflow is that, if you're using an executor like Kubernetes, it is very difficult to, develop and test locally.
We would just make a code change. We didn't really test it locally. We just figured we would hope that it worked.
There's no version controlling for tags. This feature has been talked about a lot. So for instance, if you delete a task from your tag, all the metadata that's related is lost, which is a big pain point.
It was not clear where the data was going, what it was pulling from, and how those things were happening.
Locally, you're developing on different versions of Python modules, whereas in production, you might not have the latest versions of those modules, so can lead to dependency conflicts.
A lot of times our instances would just completely be unresponsive, which forces us to go in and restart all of the Kubernetes clusters as well as the entire Airflow composer cluster.
Hi, everyone. Thanks for coming. My name is Nick Schrock, the CTO and founder of Elementl, the company behind Dagster, and welcome to Airflow Migration Day. Airflow is a widely used technology that was a big step forward for the data ecosystem when it was released. However, times have changed and technological choices must change with them. The demands on data teams in today's world are intense, and they have overwhelmed Airflow's ability to serve those teams. It's time to move on to better solutions. The goal of this event is to demonstrate why this is true, why the next generation orchestrator is Dagster, and to show, if you are stuck with Airflow, how you can migrate both with process and with our amazing tooling. You're going to hear a lot directly from our customers. And when you have a product people love, it makes putting this event on, this type of event, really fun and really effective. And it just requires a simple strategy. Just put our customers on camera and let it rip. There are a ton of great takeaways from those talks, but two facts stick out. The first is that in 2023, data platforms are utterly essential to the success of modern organizations. And the second point is that the teams charged with building and deploying those data platforms face fundamental and essential challenges executing on this mission, especially when they use Airflow. We'll talk about three foundational challenges that teams typically face. The first, developer experience. The second, fragmentation, both across tools and teams. And the third is technical debt. Let's start with developer experience. You'll hear all of our customers talk about the quantum leap improvement in developer experience when they adopt Dagster. When we talk to most data teams, the state of their developer life cycles is pretty abysmal. Most tools were not built with the local development lifecycle in mind. They were not built with testability as a first-class concept. The results are extremely slow, fragile development life cycles. This developer experience problem must be solved in order to move the data ecosystem forward. And it's truly hard to overestimate the number of dimensions that improved developer experience delivers on. I think the most obvious one is that engineers are more productive and efficient, but this just scratches the surface. Transformational DevX improvements improve the quality of the end product and even the way that organizations function. With fast feedback loops and automated testing, engineers no longer experience fear and anxiety when they make changes to the system. They move faster and more confidently and with greater quality. This in turn frees the engineer's mind to think bolder and bigger. Productivity is not just making existing tasks more efficient. In software engineering, it makes entirely new things possible. Productivity, put another way, productivity transforms the mindset of an engineer from scarcity and fear to abundance and confidence. This leads to the next challenge facing data teams. Data platforms are typically extremely fragmented across tools and technologies. Platform teams integrate dozens of tools across teams in an attempt to assemble them into a coherent data platform. In order to synchronize operations, they might adopt Airflow, but they're quickly drowning under the complexity once they adopt it. We are left with a disjointed data platform with disconnected tools and siloed teams. Developer experience does an important thing, and you'll hear this from our customers. It actually incentivizes teams across the org to adopt the technology to improve productivity and happiness. But that unleashes new organizational dynamics. You'll hear our customers use the word collaborative. You don't hear that word often enough when it comes to data platforms. With Dagster, the organization has shared context on all assets under management and a single pane of glass to debug technical issues that crosses organizational boundaries. The developer experience incentivizes everyone to get on and join on a unified control plane across the data platform. This is a novel development, and the norm in the industry now are siloed ML, analytics, and platform teams using disconnected tools, and we think a better way is possible. The last challenge we'll talk about is technical debt and being stuck with existing solutions. Today, you're going to hear from customers who have overcome that challenge. Stephen from Whatnot is going to explain how they transitioned their mission-critical, multi-persona data platform to Dagster, while incrementally building trust in the tool and incrementally delivering value at every step along the way. Then we're going to hear from Gu from Group 1001, and he's going to describe this magical experience of using our Airflow adapter layer, which is releasing to 1.0 today. It is a toolkit where, with minimal work, you can import your existing DAGs into Dagster and execute them natively. It sounds impossible. It sounds like BS, but it's not. You're going to have to see Odette's demo. Group 1001 migrated all of their DAGs from Airflow to Dagster in 3 days, immediately radically improving their DevX, and they were able to decommission their entire Airflow infrastructure, all with minimal code changes. In short, reimagined orchestration is a linchpin technology that can change the entire mindset of all stakeholders in a data platform from scarcity, where engineers are just desperately trying to keep their data platform alive, in constant fear of what will break when they or their stakeholders change anything, to one of abundance and confidence, where engineers can think about how they move their platform forward and compound value for them, their stakeholders, and their organization. Thanks again for coming to Airflow Migration Day, and I hope you enjoy the presentations.
Hello, I'm Sandy, and I'm the lead engineer on the Dagster project. Before Dagster, I spent years as a data engineer and machine learning engineer, and I used Airflow extensively in those roles. I joined the Dagster project in large part because of my frustrations with Airflow. I found that I was spending more of my time fighting with it than writing the data and ML pipelines were my actual job. I'm going to spend a few minutes here talking to you about why that is and what makes Dagster so different from Airflow. Data practitioners use orchestrators like Dagster or Airflow to build and run data pipelines. The point of a data pipeline is typically to produce and maintain a set of data assets, like tables, files, or machine learning models. Accomplishing that usually requires modeling a graph of computations and intermediate data that get you from the source data that you're starting with to the data products that you're trying to create. Airflow helps out with this because it's a workflow engine. It models a graph of tasks and executes them on a fixed schedule. It was the first Python-based workflow engine to have a full web interface, which set it on the road to become one of the most popular tools for running data pipelines. But first does not always mean best. Airflow is designed in a way that we believe actually makes it a poor fit for this task of building and maintaining data pipelines. Its design is a product of an era when software engineering principles hadn't yet permeated the world of data. And as a result, it takes a very narrow view of data pipelines. It often misses out on the bigger picture of what modern data teams are trying to accomplish. First, it schedules tasks, but it doesn't understand that tasks are built to produce and maintain data assets. And second, it's focused on production environments that support heavyweight infrastructure with long-running processes. It makes pipelines hard to work with in local development, unit tests, continuous integration, code review, or debugging. Taking this narrow view has some material consequences. First, it results in low developer productivity. Iteration cycles are slow when pipelines can only execute in production, and it's cumbersome to translate a pipeline of data assets into scheduled workflows of tasks. Second, it results in poor reliability, because if you can't catch errors before your changes make it to production, you'll catch them in production. And third, it makes it hard to understand what's going on when a pipeline is deployed, because it mainly gives you visibility into what tasks have run, not what data assets have updated. Dagster takes a broader view. It was designed to assist with the holistic task of developing pipelines of data assets and evolving those pipelines over time. We believe that taking this broader view can make data teams dramatically more productive and make data pipelines dramatically more reliable. To make this more concrete, let's start by zooming in on these phases of the development lifecycle. What's the difference between Dagster and Airflow when developing data pipelines? Developing with Airflow is difficult because Airflow pipelines are heavyweight and difficult to run quickly as part of an iterative development loop. All Airflow runs go through its scheduler loop, which means that to run any pipeline in Airflow, you need to have a long-running scheduler process that's monitoring a database. And after launching a run, you need to wait for the scheduler to see it. Also, to avoid dependency conflicts, most guides recommend defining Airflow tasks with operators like the Kubernetes pod operator, which dictate that the task gets executed in a particular environment, like Kubernetes. When a DAG is written in this way, with the pipeline bound to a particular execution environment, it's near impossible to run it locally or as part of continuous integration, unless you want to set up a Kubernetes cluster on your laptop. Dagster, on the other hand, was built from the start to support rapid development and prototyping of data pipelines. Dagster's programming model encourages separating business logic from infrastructure. This means that you can have a pipeline that runs distributed across Kubernetes when in production, but also run it within a single Python process during a unit test without sacrificing dependency isolation. Dagster execution is extremely lightweight. It doesn't require any long-running services or schedules. If you do want to access Dagster's UI, you can just type dagster dev in the command line and be up and running. Dagster also has rich testing APIs, which make it easy to write unit tests for any component of a data pipeline and to stub out external services that the pipeline interacts with. Another big difference between Dagster and Airflow is the abstractions they offer for building and operating data pipelines. Dagster sees the goal of a data pipeline as producing a set of data assets, like tables, files, or machine learning models. Dagster's programming model and user interface are heavily focused on that goal, so it allows you to think in assets when you're building and operating your data pipelines. Airflow, on the other hand, is primarily a task orchestrator. An Airflow DAG is a workflow of tasks connected by execution dependencies. Airflow recently introduced a dataset abstraction, but it's bolted loosely on top, not a core part of the operating model or programming model. Thinking in assets allows you to express your intentions more directly, which means less code boilerplate. As an example, here's a comparison of the same data pipeline written in both Airflow and Dagster. The pipeline has one data asset that's derived from another data asset. With Airflow's APIs, you need to tell Airflow that the task building the second asset should run after the task building the first asset, and then also read from the first asset in the second task. It's a lot to keep track of. In Dagster's APIs, you just express the dependency between the assets in one place. After you've written your data pipeline, you typically use your orchestrator's web UI to monitor it. Airflow's UI is primarily concerned with what tasks ran, but Dagster's web UI, which is pictured here, also focuses on the data that was produced by those tasks. It makes it easy to include metadata about that data and track how it evolves over time. Another benefit of Dagster's asset focus is that it enables much deeper integrations with modern data stack tools. For example, consider dbt, which is a tool that helps analytics engineers write SQL to build tables. Airflow focuses on tasks, so it represents the entire dbt model graph as a single node in its DAG. In Dagster, dbt models are easy to represent as Dagster assets. This means Dagster can represent the full dbt graph, which makes it easy to understand the relationships between individual dbt models and other data assets. It also makes it easy to run individual dbt models and track which models completed successfully. We only had a short amount of time, so I didn't get to a bunch of the other differences between Dagster and Airflow, like how they handle dependency isolation, event-based execution, or upgrades. But I hope this gave a high-level picture of how the two systems compare.
fundamentally, teams are excited to build, workflows in Dagster, and they're tired of doing it on Airflow. And that's a significant element to a choice in technology. The ability to attract talent to do a particular piece of work over a long term, and also to minimize, fatigue and churn. And then when the teams are using Dagster against Airflow, like we see a far higher rate of development. They're able to close the loop far quicker. Dagster has a really amazing platform to be able to develop locally as well as in your deployment, using like branch deployments, things like that. And teams are able to iterate very quickly, try ideas out very quickly, and put in production and have them work. And then what I'm seeing with teams is that the testing of those of the orchestration, the automation, and the workflows that you're able to build, it's not an afterthought, right? It's kind of, you don't have to bring that to the table. Dagster does it for you. With other tools, you often have to create that yourself. And kind of finally, and this has been my experience a few times already, is that when you encounter issues, we're able to get in touch with the team directly. They have an open Slack channel where you're able to communicate with them and resolve issues that you'd think would take you a week or something like that, but actually get resolved very quickly. So that allows you to mitigate risks and to overcome bottlenecks quicker than you expect. It really creates the incentive to have a single control plane end to end for all your data, right? And what you see with time is that teams will integrate into Dagster earlier and later portions of the data cycle that would normally be handled by other pieces. And so it creates the incentive to be more transparent with all the steps that are involved with the data. The reason why we see people go for Dagster instead of Airflow is honestly kind of a multifaceted question. The first thing is that the experience for end users, the user interface and all that is, from our point of view, more approachable than Airflow. You get the information faster. Things like error logs are just a click away, right? Instead of 3 clicks away. So it's details like those. It's an appealing platform that is pleasant to use. And that matters more than you think on a day-to-day, right? Then we find that we have to write less code in order to produce the end result that we want. The dependencies being determined implicitly rather than having often to be specified explicitly is something that it avoids redundant code and makes it easier for teams to collaborate. The availability of a platform like Dagster Cloud Serverless really means that teams can consider using it far earlier than Airflow in our experience. You have this sort of low barrier to entry in order to start using the product there for even small teams, and it's able to grow with you and has all the same ability to deploy hybrid or on-prem as you would with a more complex tool like Airflow, but you're able to approach it far earlier in your journey. We use DBT quite a lot, and the ability to get going with DBT and Dagster really, really quickly, like in the matter of a day, it's really kind of a game changer for us. Like typically with DBT, you'd go from something that's a little bit too rudimentary to then having to make the massive jump to using Airflow, and you would only do that for really sophisticated teams and quite large teams, right? Whereas with Dagster, you're able to kind of, from day one, if you want, even with a team of one, even a very small team, if you're using something like Dagster Cloud Serverless, you're able to have that tool right away. And the level of technical debt that you're experiencing is very low. So for us, it's just far broader in terms of the teams we can introduce it to. And we're seeing teams that are very small asking us excitedly about it or asking us to implement it for them. And I mean teams of 1, teams of 3, things like that. Because for them, the trade-off between technical debt and the value they get is overwhelmingly advantageous.
implemented. We are implementing Dagster for some of our clients. They're very happy with the tool. I would say that with Dagster, there's a lot more collaboration that gets introduced. This collaborative effort into developing data products is something that Dagster outshines Airflow any day. Previously with Airflow, you would have these segmented teams that would essentially manage a lot of its components. But with Dagster, you can get a single unified view. You can involve a lot of teams into visibility of data pipelines. In terms of DAGs, there's a lot less code to write, especially with Dagster's inbuilt classes and inbuilt API methods. They're very efficient. They're reusable, pluggable, following the DIY principles. So with Dagster, you kind of think, it basically enforces you to think in a very modular fashion. But Airflow, I feel, is still a long way to reach this level of modularity. There is a lot of flexibility around deployments as well. The biggest one is the branch deployments, which saves a ton of effort and dev time when you're developing collaboratively and when you're doing integration end-to-end testing for your data pipelines. It automatically creates that, replicates the production environment without having the data engineers, to do anything or set up the infrastructure. Rather than think of tasks as workflows, essentially, just a bunch of tasks, Dagster treats these jobs or DAGs as data assets and helps build on top of these data assets, whether it's a TBT model or it's a data frame or any transformation, and then further leverages these assets and builds features like asset catalog, observability logs right from its UI, which is very helpful.
Hi, I'm Pete, CEO at Elementl. And today I'm going to talk to you about Dagster-airflow. But before I do that, I want to talk to you about how you evaluate technologies. So if you're looking to bring a new technology into an organization, you really need to answer two questions. The first is this the ideal end state? When you adopt this technology, does it actually solve your problems and the problems of your stakeholders? And do you think it will be durable over a long period of time? Second is there a timely and practical path to get there? So when you think about the path to adopt the technology, is it even practical to get to that ideal end state? And so we spent the last year or so talking to Airflow shops about Dagster, and the vast majority of them would say, hey, Dagster might be the ideal end state for us. And hopefully the talk from Sandy earlier convinced you of that too. The real challenge here was this second question, the timely and practical path to get to that ideal end state. And so we've addressed that problem with the release of our Dagster-airflow integration today. So with this package, you can run your Airflow DAGs natively on Dagster. You can extend them with software-defined assets or Dagster's ops and jobs. You don't need to modify your existing Airflow code at all to take advantage of this. And you don't have to run your existing Airflow instances anymore. This runs entirely within Dagster. And yes, this actually works. We've gone to production with design partners with this, and as crazy as it sounds, it does actually work. And from the Dagster side, it's really just a one line of code integration for the most part. You import the library, you pass it your Airflow DAG, and you're off to the races. So with this capability, you can import your Airflow DAGs and run them on top of Dagster. This means that you can take advantage of all the Dagster and Dagster Cloud features with very minimal or no code modifications. So this includes our beautiful modern UI. This includes taking advantage of software-defined assets, fast local development, one of the most common Airflow pain points, testing, another extremely common Airflow pain point, Branch deployments, this is a feature that we shipped last year that lets you get an ephemeral staging environment for every pull request, making testing extremely easy and code review very easy. You can take advantage of other features like declarative scheduling, our SOC 2 and HIPAA compliance on cloud, and our hybrid cloud and fully managed serverless cloud offerings where you don't need to run any infrastructure at all. And finally, with Dagster, you can run multiple isolated environments on a single instance. This is something that Airflow can't do and is one of the main reasons why users have switched from Airflow to Dagster in the past. What's important here is that this enables you to migrate your code incrementally over time. So before this integration, oftentimes you had to run two separate instances, your Airflow instance and your Dagster instance, keep them running in parallel for a while, and then you had to do a big, large migration. You basically had to do the whole thing at once. With this, you can move your Airflow code over incrementally. So you move it to Dagster, shut down your old Airflow instance, and then over time incrementally migrate the code. Now this is all really great, and we did launch it to 1.0 recently, but we are still early. So while this does support many of the features that you would expect from Airflow, like schedules and XComs, there still are some rough edges here. So join our Slack channel or check out the docs at docs.dagster.io to learn more. Thanks for listening, and I'm going to hand it off to Odette, who's going to demo this.
Hi everyone, my name's Odette and I'm a developer advocate here at Elementl. So as Pete mentioned, it's not only critical to choose the right technology for your future, but also to consider the path to getting there. So what I'll be showing you today is our lift and shift tool, which takes all of your different Airflow DAGs and migrates them onto Dagster as jobs, which will enable you to test locally, run the code locally, as well as deploy to our cloud serverless option in just a couple easy clicks. Okay, to start off with, I'm going to show you a bunch of different Airflow DAGs. So you'll see different schedules that we might have, a bunch of different DAGs, and you'll be able to do this process with your DAGs that you have already built. What I'm going to show you is how to take all of these DAGs and migrate them into Dagster, and you'll see that you don't need to set up any infrastructure, and you'll be able to run and test this locally and very simply. So this example is actually available on GitHub, and you'll be able to follow along, as well as use this as a template to replace your own DAGs in here. So what I have here is a bunch of different folders. I'll start off by showing you a bunch of the different DAGs. I'm going to show you this tutorial DAG. So this should look like standard Airflow code. And what we'll be doing is take this Airflow DAG and turning it into a Dagster job very simply. So you won't need to change any of this code. What we'll be doing is actually wrapping Dagster around this, and you'll see that there's no code changes and no infrastructure set up to both edit and run this locally, as well as on the Dagster cloud. Next, let's take a look at the tool that's making this happen. So I have this Dagster migration folder over here, as well as this definitions file. So we'll be using a library called Dagster-airflow, which takes all of this Airflow DAG code and is actually going to not change that code a bit. You don't need to write any Dagster code as well. And what this is going to do is create the definitions path from those DAGs in one or two different commands. Now that we peek behind the scenes to see the different Airflow DAGs, as well as the tool, which is Dagster-airflow, which is going to make this happen, let's open up the README file and let's see how to run this locally. What I have here is two different commands that we're going to run. The first is going to install both Dagster-airflow, all the different dependencies, as well as this Dagster migration file. And the second is Dagster dev, which launches the UI. So let's get started and execute these two commands. And that's it. So here we have all our different Airflow DAGs, which have now been converted to Dagster jobs, all ready for us. We'll be able to run this, have all our schedules working, running it locally, making changes. And this is really the first step in migrating to Dagster, because now you have all of your existing ETL processes, whatever workflows you had, up and running, and now you could transition over to things like Dagster assets, which Tim will be demoing in the next video, very slowly with everything working and your core business operations untouched. So let's go into this Airflow tutorial. So you'll see that Airflow has been appended to each of these DAGs, just so we know what's been migrated and what hasn't been. You'll see the different Airflow tasks, which have now been converted to Dagster jobs. And let's see how this works. So let's run it. So right now we're running all of these Airflow DAGs locally with a couple easy commands got us here. So you'll be able to really test this out on your Airflow DAGs yourself. And we do recommend that you start off locally before going into cloud, just to make sure everything's working. And that's it. Everything has now been migrated to Dagster jobs, and we're executing this locally. Now that we saw how to run this locally on Dagster, let me show you how to run this on Dagster Cloud. So this is our serverless option. We also have hybrid, so you'll be able to use your own infrastructure. But our Dagster Cloud serverless option requires 0 infrastructure setup on your end. And what I'm going to do is actually just run these couple commands, and you'll be able to see that everything is pushed to Dagster Cloud, and you'll be able to run all of the different Airflow jobs there. So here I have my Dagster Cloud, and you'll see that we have different code locations, which will enable your teams to really collaborate here. So no longer do you need to have one person editing code on their end and not able to look and see what else is going on in the rest of the organization. Here you could have all your different code locations, which could correspond to different projects that are being worked on, and you really could have that strong collaboration between all of your data team as well as your analytics, machine learning teams as well. So here we also have our Dagster migration folder. You'll see all of the different Airflow jobs, Airflow DAGs that have been converted to jobs here. And you'll be able to run this as well. Okay, so now that we've been able to run all of our different Airflow DAGs on Dagster locally, as well as on the Dagster cloud with our serverless option, you should be able to spin down all of that complicated Airflow infrastructure that you have had running for the past couple years. So the last thing I'm going to show you today is how to unit test your code. So in Airflow, you might have been pushing changes to production with maybe low to no confidence of how it will actually work. Not a lot of testing to make sure that everything was working fine with your data, to make sure that your production instance is intact. So what I'm going to show you right now is how to do a couple unit tests. And these are going to show you how to execute the jobs, as well as to make sure all the different outcomes are as expected. And you'll be able to do this for your Airflow DAG side effects. So if you have any side effects that are being created as part of your existing Airflow DAGs, you'll be able to test that. And once you get into Dagster and the different assets, you'll be able to even run more robust tests on what you're expecting as part of your data pipeline or machine learning pipeline. So you'll really have confidence that you could unit test every little piece of your pipeline before moving to production. And when you go to production, you'll see that you have tested it and there should be no issues there. So here I have a bunch of different code. You'll see that we're testing to make sure that everything was successful. We have the different package in here, which is dagster-airflow, which loads in all of our different DAGs as definitions. And what I'm going to do is actually run this to see that everything was executed successfully. Okay, now everything has been passed. We can see that our test passed here. And I'm really excited for you to hear Tim in the next session on how to turn all of these Dagster jobs into Dagster software-defined assets, which will really unlock the power of Dagster for you.
Hi, my name is Tim, and I'm also a developer advocate. My colleague Odette just showed you how easy it is to lift and shift your Airflow DAGs and run them within Dagster. Now that's great and all, and you're already getting some benefits from using Dagster. But as others have mentioned, There's so much more you can do once you move to an asset-focused view of your data pipelines. Let's take a DAG written for Airflow and move its logic into pure software-defined assets in Dagster. While doing so, we will cover our recommendations and best practices while refactoring. Before diving in, it is important that we make sure we know the right lingo between Airflow and Dagster. Thankfully, if you head on over to our documentation, click on integrations, and navigate to the Airflow page, you have some resources prepared for you. Here is a table that covers similar terminology between Airflow and Dagster, along with their differences. The big ones worth highlighting for this migration are that there are no operators in Dagster. We use normal Python functions, which allow us to test our logic better. I/O managers are Dagster's way to set up connections with external services, such as Amazon S3. These are similar to XComs and hooks, but are more powerful. This creates for less overhead when dealing with data that is large, complex, or in separated systems. You'll also see how it leads to cleaner code, and once again, it's easier to test. Assets are Dagster's bread and butter. Dagster has extensive metadata-driven features built around assets, such as partitions, lineage, and declarative scheduling. You may have tried Airflow's datasets, but software-defined assets will help you enjoy working with your data pipelines again. Now that you know the concepts, we can start talking about patterns for refactoring the Airflow logic into its analogous Dagster code. We will refactor our DAG one task at a time to use less Airflow code and more of Dagster's concepts, piece by piece, without breaking production. Because of our Dagster-airflow utility package, we can connect newly made assets with the assets that are made from the Airflow DAG. In this case, we'll start from the beginning of the DAG and work sequentially, one task at a time, to the end of the DAG, replacing each piece of it. Using this pattern, we can replace the Airflow task with Dagster assets at our own pace. Let's go see this in action. Here is the DAG whose logic we'll be refactoring today. There are two tasks. One task queries Hacker News for all IDs for the current top stories and saves this list into an AWS S3 bucket. The next task reads that newly made file, iterates through the IDs, and gets the titles for each story. Let's start taking our logic out of Airflow and moving it over to Dagster. Here is our starting point. We are using another utility function from our Dagster-airflow package called load assets from Airflow DAG, which helps you start thinking about your existing data pipelines as assets. You can map tasks in your original Airflow DAG into assets in Dagster and create dependencies to any assets. You can see this mapping in these two parameters. Use this when you're ready to migrate an individual DAG's logic over. Keep using that function that Odette showed you earlier to move all of your DAGs over, and use this one once you're ready to make the most out of Dagster with an individual DAG and you're ready to refactor. Here is that DAG represented as assets in the Dagster UI. Like this asset over here is made up of a task in Airflow code, and we are going to take this one and migrate this logic over to being purely Dagster native. Let's cut and paste this task from the Airflow section and move it over to a new function in our Dagster project. Now we'll clean up this code to make it into a true software-defined asset. We'll first add the asset decorator. Then we'll return the IDs rather than sending them to S3, because now we can use I/O managers, which we talked about recently, to deal with reading and writing data for us. Finally, we'll patch up the asset dependencies so that our new asset replaces the old asset made by our utility function. Once those steps are finished, let's run it to test that it works. See that since we added the asset and removed the old task, it works just like it did before. This is code that can be readily pushed to production, meaning that you can take your time and you don't have to do this refactor all in one sweep. Once you validate that logic produces the right output, you can move on to refactor the next task. Once you've migrated all of your Airflow DAG to software-defined assets, now you can feel the satisfaction of deleting the old Airflow code and depending purely on Dagster.
Thanks, Tim, and thanks, Odette, for showing us how that works. Now, let's hear some stories from some users.
I think what stands out for Dagster is its focus on engineers, and in particular, engineers who are managing data assets.
When the teams are using Dagster against Airflow, like we see a far higher rate of development. You know, they're able to close the loop far quicker.
When you are doing integration end-to-end testing for your data pipelines, it automatically creates that, replicates the production environment without having the data engineers, to do anything or set up the infrastructure.
Availability of a platform like Dagster Cloud Serverless really means that teams can consider using it far earlier than Airflow in our experience.
Create branch deployments and see changes live was just a huge shift in the experience compared to Airflow.
We're able to execute that Kubernetes pod operator locally after 4 hours of just testing it out. That was phenomenal. We've never seen a true local Airflow execution of that before. But with Dagster, using the actual Dagster-airflow migration, we're able to get that up and running.
This collaborative effort into developing data products is something that Dagster outshines Airflow any day.
If we can actually make a change, whether any business SaaS, whereby a business SaaS had an idea, an insight, where let's say they want to be able to take a look at from a productivity standpoint of all of Jira tickets, all of our, not Jira tickets, but our Zendesk tickets that are coming in regarding our cases that our customers have submitted, and to be able to identify where the operations team is efficient or inefficient. That insight, that idea, if we would explain it, if we do it in Airflow, it probably would take us maybe 2-3 months to even get the data in place where we can actually begin to figure out a sort of insight, to build a visualization, to build a dashboard. And the way I would sell it is, instead of 2-3 months, what about 3 days? That's the difference that it would take to move over to Dagster. It's just, instead of 3 months, we can do it in 3 days, just simply the accelerated development cycle from that perspective, ease of development, ease of troubleshooting and monitoring, and the fact that we can actually reliably make changes without breaking any of our existing processes. And that's the way I would sell it that's the way I've been selling to the business. Just really, what if I could take your idea from 3 months request down to 3 days? Then there's no question asked. Let's do it, because then we can deliver more insight, we can deliver faster value, because speed is actually what we care about. The speed is really where we can actually drive our competitive advantage within our company. Our entire architecture really centered around Airflow with our own Python processes that were running the Kubernetes pod operator. We ran into a load of different issues. The biggest pain point that I've generally seen in terms is really, number one, from a stability standpoint. We've had numerous outages whereby Airflow just simply wouldn't run our jobs, refused to run our jobs, or sometimes the Kubernetes pod operators just fail to even start, or just fail midway during the processes. And these tend to happen maybe once a month, but once a month is just far too many from my perspective, especially since it's just Kubernetes that wasn't able to trace it from that perspective. So from a stability standpoint, it was a big issue, and a lot of times our instances would just completely be unresponsive, which forces us to go in and restart all of the Kubernetes clusters, as well as the entire Airflow composer cluster. So stability was a very, very big pain point for us at Airflow. The second bit of the biggest problem that I've seen, number two, was really regarding our end-to-end cycle time. So from a development experience perspective, running any sort of changes to our DAGs and Airflow, just due to the complexity with using the Airflow version 1, we never actually did our changes locally. We would just make a code change. We didn't really test it locally. We just figured we would hope that it worked, send it through the CI/CD pipeline, commit the code, push the feature branch in, have it deploy into our dev environment that's on Airflow Cloud Composer. And then we would be able to start the job and run it to be able to test the change. from a code change to a code commit to a CI/CD process to actually starting the job, that is already 8 minutes to get it from the code change to deploy and have it. Because even when you deploy to Airflow, even though it's done deploying, Airflow, because of the slowness of the scheduler to refresh the DAG metadata, it takes about a good 2 minutes to refresh. And even when you start the job, it takes about 2 minutes to have the pod actually start up and run the job. So we're talking about an end-to-end cycle time of to even do one iteration of our change, not even an end-to-end cycle time. Just even one iteration of a change is 10 minutes. When we actually spoke with the Dagster team, they mentioned they had this Airflow migration capability, and it was phenomenal. Actually, when we actually set it up and configured it, in working with one of our engineers with Joe, in about 4 hours later, once we got it configured, we were able to run Airflow 1.10.15 locally in a development sandbox on our Macs that we've never done before. Executing our Kubernetes pod operator DAG using the Docker image that we had from our Google Cloud repository that we pulled down locally. We're able to execute that Kubernetes pod operator locally after 4 hours of just testing it out. That was phenomenal. We've never seen a true local Airflow execution of that before. But with Dagster, using the actual Dagster-airflow migration, we're able to get that up and running. And then in 3 days later, we migrated all of our 73 different DAGs over to Dagster. And then in 2 days later, we set up the GitLab CI/CD pipelines, and now we're publishing our assets into Dagster Cloud and deploying it. So I think we really benefited from this collaboration and speed that Dagster provided here, while having significantly better development experience, while at the same time running Airflow locally better than what we could run Airflow locally had we done it ourselves. What I definitely recommend from a best practice perspective is take a look at Dagster, take a look at its ability to run the Airflow migration, and think of it as a way of a stepping stone. It's a way to really be a stopgap. You can migrate, lift and shift all your existing DAGs onto the Dagster platform. You get to leverage Dagster's really well thought out end-to-end SDLC experience. So you're able to cover the migration standpoint, but you can actually use the platform to reinvent and redesign those pipelines in a new manner that will get you better agility and better scale. So that's the way I kind of frame it. And that's our actual plan and vision for using Dagster. We don't plan to keep our Airflow DAGs for the long term, but nevertheless, in the short and medium term, we're able to leverage Dagster to really get off of Airflow first. And then we are able to rebuild these pipelines such that now we're going to have the agility and scale that we need going forward. And that's what I would think from a migration standpoint is how you can how you can ease it in, because it de-risk it, because you're just doing a lift and shift. There's very little risk from that guard. It makes it very easy to regression test and deploy. And at the same time, you're getting rid of old infrastructure. And at the same time, now you have a new development platform. And then from there, the rest is just, delivery on the rest of the migration there.
Hey, I'm Joe. I'm an engineer here at Elementl. I'm going to go over a few considerations for you to keep in mind as you're making your migration from Airflow to Dagster. As you've heard from Tim and Odette, the migration tooling and the Dagster Airflow library are really powerful, and they give you a lot of leverage. But making migrations is complicated. And so we really recommend that you first focus on getting things running locally and establishing that tight iteration loop that allows you to incrementally take on more migration scope and quickly validate that this approach is going to work for you. You heard from Gu at Group 1001, and this process of setting up that local development environment only took them a couple hours and was really key in enabling them to migrate a lot of DAGs in only a few days. Secondly, make sure you're the right person for this job. You're going to need to understand Airflow, and specifically how your team uses Airflow, the operator types, and the configuration and permissions that are needed for things to execute successfully. And you're also going to need to understand and be comfortable interacting with the infrastructure that you run Airflow on. Whether that's Kubernetes or some other cloud provider, you're going to need to be comfortable pulling out the permissions and configuration and porting it to wherever you end up running Dagster in production. And finally, for making the decision of where to run Dagster in production, we'd really recommend Dagster Cloud. The serverless deployment option is going to be amazing if you're a team that doesn't want to manage their own infrastructure or isn't comfortable managing their own infrastructure. The built-in environment variables feature unique to cloud is going to make porting things like Airflow variables and secrets that are needed by Airflow connections a lot more seamless. The built-in CI/CD is going to let you not have to worry about how to make and distribute deployment artifacts. And then the branch deployment feature is just going to blow your mind when you test it out and will be game changing for your development and kind of testing story. All right, that's it. Happy migrating.
Hi, I'm Stephen Bailey. I'm a data engineer at Whatnot. Whatnot is a live stream shopping platform, kind of like a Twitch meets eBay, where we allow enthusiasts to make a living selling things they're passionate about. So if you're in my position, the position I was in, where you're evaluating orchestrators and you're going to commit to one for the foreseeable future, I would recommend. Well, first of all, I would say Dagster is fully production ready. It's like coming into this exploration, you have to ask that question of is a startup, going to be stable enough for you to build your platform on? We've had zero issues with stability in the platform from the beginning. The second thing I'd say is you want to focus on the value add part, which is an ergonomic experience for your developers and just the agility to getting new pipelines out and plugging them into your existing architecture. And to that extent, I think Dagster has a couple of really great features that it offers. The first is the built-in GitHub Actions. The second is the serverless deployments. So if you can not think about infrastructure for your first transition, for your first several pipelines, that's a great win. And it means you can focus on building out your graph of jobs and pipelines. The third thing I recommend is using the new asset functionality. That's really where Dagster starts to differentiate itself from other competitors, and also becomes a little more compatible with other modern tools like dbt. So the project plan was to lift and shift everything. That was the goal. And we started with a couple of key pipelines, moving them over to Dagster, and really getting the Dagster workflow and developer experience, including things like how does the Python package look? How do we set up the CI/CD? How do we set up notifications? How do we just get accustomed to all of the new APIs? So we took a couple of trial pipelines, moved them over, ran them in production, and deprecated them in the Airflow instance. And then there was this period of just migrating pipeline after pipeline until we had just a couple of residual ones left in Airflow that we really kept going for quite a while, just as a sort of fallback in case anything happens. We migrated our first set of pipelines, and then we kept a number of them going at the same time as Dagster pipelines were running, just as a sort of backup in case anything went wrong. I think our experience was a little bit like dating, where it takes a couple months for us to build trust in the relationship, trust with the new infrastructure that stood up. We had some Kubernetes issues where pods were getting killed when things were getting scaled, and so it just the migration takes a little bit of time for everyone to build confidence in it. But then what we found was that there's definitely a tipping point where having everything in Dagster became a much faster workflow, much more visible. You'd go back to our Airflow workflow and you kind of be like, oh, what is this? And at that point, we were really able to pull off everything from the Airflow instance and just make it in Dagster. And during that process, we improved most of our DAGs. So we were able to pull over, it's mostly Python modules, so we pull over the functions and just kind of wrap them and run them like we would in Airflow. But during that process, great opportunity to go in and fix some pipelines, harden configurations that were a little squeaky in the Airflow pipelines. And it was really a good opportunity for us to really put that long-term vision of, very stable platform and just refresh some of our core processes. All of these data assets that you have out there can be Dagsterized and connected to your other processes. And that's a huge unlock for our team. It allows us to move to a much more event-driven architecture where DBT refreshes things and then everything that's downstream of those pieces refreshes things. And that's the sort of next level of orchestration that we really wanted to get to, where things were much more event-driven, not just a bunch of schedules that we didn't really know what was hitting what. And so I would recommend starting there. So, ignoring infrastructure if you can, using all of the built-in CI/CD and actions that make things easy and nice, and then focusing on building out your asset graph and leveraging all of that potential early would be the three things that I would recommend. There are some features in Dagster, like the assets, that make it a little easier and make it not just a net move, but a net improvement. The migration challenge is going to be proportional to your DAGs, your footprint in the orchestrator. And that can be challenged. I think the other piece there is what your DAG dependencies are. Because if you have triggers in Airflow where one DAG is triggering another, and then custom alerting is built on top of that, those things do take time to migrate over.
So that's all the programming we have for today. Thank you all for coming to Airflow Migration Day. If you'd like to learn more, please join us on our Slack community or check out our docs at dagster.io. Thanks and have a great rest of your day.